Hope my screen is visible.
Yes.
Right. So yeah, Saurabh, Thursday we discussed one problem, right? That analyzing a transcript
Yeah.
of a meeting
Yes,
of
yes,
let's
yes.
say 2 hours. So any
Mm-hmm.
inputs on that?
Uh, no.
No inputs. Okay.
Uh,
Okay. So Manoj, yeah, you can we can present your idea.
Okay. So what the LLM has suggested me about this is we are asking
Okay.
agenda or three agendas, which is summary, XML diagram, and description from a
Correct.
2 hour meeting.
Mm-hmm.
So the agent we need to design five agents here.
Okay.
First
5 agents.
agent, yeah, the first agent is ingestion agent, and from that we get audio transcription, diarization, alignment, which is like splitting audio into parts, like whoever the speaker, like speaker one, speaker two, speaker three,
Okay.
and lining up those speaker parts with words and timestamps.
Okay. So this is which mode? Like, is it text you are passing the transcript, or is
Yes,
it
yes.
the recording whole thing?
Uh, yeah, recording and sending it to the agent. I mean,
The whole
this.
recording, you
Uh,
mean
y-
video and audio, whatever presented, everything?
correct. Yes, yes.
Okay, so it's not a text, it's an multimodal input. Okay,
Mm. Mm. And the other
video,
agent is
audio. Okay, so
yeah.
that's your input. Okay, good.
The other agent is memory agent, which is converting those chunks
Mm-hmm.
into some structured JSON object.
Memory agent.
Mhm.
So, so the first thing, so you're passing it to what? So there is an agent which actually classifies this based on the speaker, the agenda, everything, right?
Yes.
So can I say there are like micro transcripts that are being generated now?
Yeah.
Okay, now these are being passed to memory agent.
Yeah.
So what's memory agent?
Converting those like whoever the speakers are there in the meeting, it will convert those chunks into structured object, JSON object.
Okay, structured
Don't know
JSON
whether
object.
I'm
So
complicating this or not.
okay, so when you say just structured JSON object, it's basically a dictionary, right? So you are passing this transcript as, let's just say there is a key. So in any dictionary, you have key and value, correct? So here key would be something like speaker one, SP1, let's just say, and the value is the whole transcript what he spoke of, right?
I'm sorry, I had some
I
disturbance.
mean, so this is chunk one, let's just say. So this is
Yes.
a whole transcript of speaker one. So this is
Yes.
passed to your memory agent, which creates a structured JSON output where
Mm-hmm.
the key is, let's just say, the speaker, and the value is, let's just say, the transcript. Correct?
Mm-hmm. Yeah.
So we're creating such three JSON output. Right. Okay. Uh, so the name is memory agent. Okay.
And then uh, summary agent, which is creating from those chunks, we are getting those
Okay.
summary.
So let's say these three are parallel now. So they are independent. Now from
Mm.
this, I create a summary, correct?
Yes.
And I create summary from this. And let's just say I create summary out of this. So are we speaking about this summary or the transcript summary?
Transcript summary.
So you have a value, which is the whole transcript that speaker one is saying, right? So we're
Yes.
summarizing this particular transcript, or are you suggesting that from this you are extracting agendas? So because the summary mentioned here is for agendas. So let's say there
Mm-hmm.
is an agenda one that's being discussed or process one that's being discussed. So we're
Yeah.
making summary of that particular agenda. So here, since you are making the summary of, let's just say on this speaker one, this particular JSON that
Mm-hmm.
contains the value of speaker one transcript, right? So are you creating summary of this?
Yes. Yes.
Okay, great. Yeah. So we have a summary of transcript. So instead of the whole, let's say 500 lines of transcript, you have a summary of, let's just say 500 words. Is that what it means?
Mm, yeah. Yeah. I would say to
Oh,
consider that.
okay, fine.
And the other one is diagram agent. From this discussion, it creates XML diagram from the
Okay, so
transcription.
now instead of the whole transcript, it considers only the summary and then it
Mm.
will try to create XML diagram out of it, correct?
Yeah.
Okay.
And description agent.
Okay, and next it will create this our description. Okay, right?
Yeah. Yes.
So this will go for all these three, I guess. The three
Yes.
pipelines, let's say. Correct?
Correct.
Okay, great. So, Saurabh, do you think would how good is this process? Any idea or any comments on this or
No, I'm
your
just
opinion?
trying to understand this one. I'm trying to understand uh, about this orchestration and the
Oh, just
problem
leave
statement.
this, leave this, leave this. This is
Mm-hmm.
completely off. Okay, I'm just using this
Mm-hmm.
background. It's a cold background.
Okay. So I thought they are interrelated, like the problem statement
No,
and
no, no,
this topic
no, no.
for today is related, I guess.
So we have explored AI agents. So we have explored
Mm-hmm.
agentic AI. So now agentic AI is
Okay.
nothing but orchestration of agent, right? So
Yes,
now we
yes.
are trying to solve a problem using the AI which we know. So you may include agents, you may not. But yeah, I will be explaining this agentic orchestration today. That's the
Mm-hmm.
agenda for today. But right now we are solving a simple problem. Let me phrase the problem again. So the problem
Mm-hmm.
is, so we have a transcript of, let's just say, for example, we are taking it to be 2 hours. Okay, it's a
Okay,
quality
meeting
discussion that
transcript.
happened with admin and its groups. Okay.
Mm-hmm.
So now the admins want an application where they want this transcript to be analyzed, and
Okay.
the analysis result of this transcript should be something like the number of agendas that's being discussed. That may be agenda one, two, three. There may
What
be
is that
one
number of?
single agenda. There could be multiple agendas.
Mm-hmm.
Sorry. So there could be multiple agendas or single agenda that's being discussed. So there could be multiple teams that are presenting their ideas to the admin or let's say CEO or CTO. Okay, the summary of it
Mm-hmm.
because they can't remember the whole thing as exactly as they have said. So they want to document this. So
Mm-hmm.
if this task is given to some human, let's say this analysis will take for let's say 2 weeks to analyze all the
Okay.
transcript and to understand all the agendas and understand the flow and present with all the deliverables. Okay. Now they want to automate this and make it fast. Okay.
Okay.
So they have given us a task to analyze the transcript and get down to the agenda number of agendas that's been discussed there. And for each agenda, they want three deliverables. That is the
Okay.
summary and XML diagram that we presented, or and another thing is process description or agenda description, you can say.
Mm-hmm. So
Okay.
summary,
So
description,
description
and
in
the
the
flow
sense
chart.
who say what and what are the major things that need to be highlighted and what is the process being discussed.
Mm-hmm.
Right. So these are the three deliverables which need to be delivered for each agenda. So they want this application.
Mm-hmm.
So to create a system design, or let's say to create such applications. And since the transcript in order to arrange them or organize them, you need intelligence, right?
Yes.
Right. So you can't just organize them based on the let's say what is it called, a timestamp, correct? So you can't
Yes.
organize
Yes.
these
Yes.
things, these meetings based on timestamp,
Yes.
correct? Because let's say there is a team one and they have started their discussion, but in between they got a mic issue or let's say their engineer didn't show up. So they may stop it and then the agenda two may start. And after that,
Okay.
they may continue with their agendas. The team which stopped in between. This can happen. And just classified
Mhm.
based on the agendas with NLP. Correct?
Yes.
NLP in the sense natural language
Literal language
processing.
processing.
So we
Yeah.
can't take up an anchor where let's say if this state comes in, let's say that's the final result of our meeting. Okay. So let's say in the meeting, once they complete their like explaining their they say like we are done with this. So we can't take done with this and then classify all the organize all the things based on this because these things are very common, right? They may
Very common in
there
the
may their program
conversation.
may not execute and later they may start again, or there somebody may have not showed up and later they have showed up, right?
Mhm.
Right. So this can happen. So including these
Yes.
particular statements or similar statements could like actually introduce a lot of edge cases. So we need intelligence here, and we have got AI with us. So we need to solve it with
Mhm.
AI application. So this whole thing is an AI application. So how would you solve it? Or what's your approach to solve it? Is the question that's being
Uh,
discussed on Thursday. We waited
okay.
for you
Okay.
on Friday, but yeah,
Mhm.
that's fine.
So, like,
Yes.
how we can build such application, right? That's the question.
So for the same thing, Manopna has presented with an yes. So we need to build this
Mhm.
application. So how will you build it? Is the question. So we have one approach which Manavina explained. Not a text, but multimodal input. Now she is passing it to an agent. She is converting that she is creating transcript out of it. Okay. So
Mhm.
depending on who is the speaker, let's just say there are three people they are discussing. So depending on the speakers, she is classifying the chunks. Okay, so three chunks here means three speakers. So based on that, she is converting it into a JSON format where the key is the speaker name and the value is the transcript. Then by considering that particular person's transcript, she is summarizing the whole thing. And then with the summary, she is creating XML and let's just say with the summary again, she is creating process description. Okay.
Mhm.
For each of the agenda,
Yes.
she
Yes.
is using this pipeline.
Okay. Okay.
So
Okay.
what do you
But
think? How
I
good is
believe
this whole thing?
like considering the speaker and the agenda cannot makes a very good output here because uh, sometimes it's like two multiple speakers with the same agenda and one speaker can go with multiple agendas. So we need to find out the context, like simplifying the context of a decision, like the sentences, like in a natural language processing, we can
Mm-hmm.
find out the context and the interrelation between them. So let's say the discussion is going about, let's say the stock market. Let's say the discussion is going on stock market,
Okay.
and the discussion going on is like what are the stocks and like, how they are going up and down and similar things. And then they are discussing about one particular stock with the, let's say,
Mm-hmm.
automobile industry. And then from
Okay.
that automobile industry, they move into the automobile sections, and from the discussion which starts from a stock, they completely went into a automobile and those things like how the brands are playing and the brand strategy. So
Okay.
this is completely different than the automobile discussion of stock markets. They were initially discussing about all the stocks. Now they are focusing on the automobile market and now the brands of automobile brands. And
Okay.
then while discussing, it could be a second agenda. And
Mm-hmm.
while discussing this, the conversation moved towards, okay, we are discussing about, let's say, the manufacturer, the car manufacturer, the importers, and
Okay.
then they move into a particular brand, and then they decides like, okay, this particular brand is in the hospitals, this particular brand is in tech. So moving towards the technology, and then they are completely talking about the current tech enhancements in the IT industries. So you can
Okay.
understand that how the conversation starts from stock market, coming to the automobile industry, coming to the tech industry. So
Okay.
this how these changes can come out to be a different agendas. Like
Mm-hmm.
we have to find out the context of the conversation, and we
Oh,
have to identify where smoothly the context is being transferred from one object to another object. So
right.
by and definitely the AI will do this, not like a code will not do this. AI has to be there to
Okay.
identify the context out of it, like the conversations, the core object of a conversation. And
Mm-hmm.
when the object is shifting from one topic to another topic, so initially the object would be stocks
Okay.
in the conversation, the stocks, the share market,
Okay.
and then the object is focusing towards the automobile, and then the object is focusing towards tech industry. So how this conversation is being drifting, that has to be identified, and based on that, the agenda has to be calculated. And once the agenda is finalized, then what has been discussed under that agenda has to be turned
Mm-hmm.
down into a pointers, and then we can come out with a description. Like once we get the pointers, after getting pointer, what is the summary of it? That and
Mm-hmm.
that's summary of it and the description. So with the
Okay.
pointers, the AI without hallucinating, it brings out the description of this thing.
Yep. That
So
makes sense.
mhm,
Uh, yep. So basically, organizing the transcripts based on the speakers. Okay. That could be very tricky
mhm.
part, right?
Yeah, yeah.
Manavya, did
It's
you
not
understand like
always.
why?
Yeah, yeah, I understood.
Makes sense, right?
Yeah.
So yeah, that could be one solid point. Okay, to start with. And what are other things where you see this could have been improved? So Manavya, where are you organizing? So this pipeline is based on the assumption that this one speaker actually speaks the whole single agenda, right? So we are creating summary of that transcript, and we are creating summary, XML diagram, and process description based on a single person's presentation. So it's usually collaborative, right?
Yes.
So the person one and person two, they may present a single agenda.
Hmm.
That is very obvious. That could be like very realistic, correct?
Yeah.
So classifying based on a single person, the single person's transcript could be tricky. Okay, for this particular application. So what else? So yeah, so this is a point. Okay, how could you improve this? Any ideas or any ideas, Saurabh? How could you improve this?
um, Make
So we
sure we do
saw.
it.
So it's usually 15K tokens in minimum. Okay, for 2 hour transcript. So we usually have 128K token context in most of the paid subscriptions. Okay, or it may be OpenAI, Gemini, or this is the minimum thing, 128K. So now it has reached 1 million context. So Saurabh, can we dump this 15K transcript into any one of these models? Okay, it's more of like a 20 to 30% of the whole context they are providing, right? So can we dump this into an LLM and ask for all these deliverables? So what could be the
So
flaws with that, Saurabh?
mm, uh, not able to understand, unable to answer this. Like, what could be the flaw?
Okay, so you want me to rephrase the question?
Yeah, yeah, yeah. Please, please.
Yep.
Let's.
So usually the OpenAI models, or let's say Claude models, Gemini models, right? Say the minimum context. So context is something which they can hold in memory, right? Correct? So now
Mm-hmm.
they have the capacity to hold 128K tokens. So
Exactly.
usually the 2 hour transcript is of 15,000. Okay, it's not 15,000K. Sorry, it's 15K tokens. My
15K.
bad.
Okay, okay.
Yeah, 15K tokens. Okay. So now can we fit the whole thing in into an LLM text and ask it to generate these three deliverables? Create an like very good prompt, very good prompt. Okay, to generate the number of agendas, and within all the agendas, the summary, XML diagram if necessary, and the description for all these agendas. So would it be feasible?
Okay, initially, if we have the transcript and we don't know what to do, then definitely we have to dump this data to LLM and let it find out some meaningful chunks out of it. Because
Okay.
what we have is a set of data, like the transcript, and without AI, we cannot do that. Like, if you want to clean this up, no, we cannot do. Like, we cannot find out like
So
what is a
so
meaningful part
the
and
approach could be, this is an LLM, and you provide your transcript to this LLM and ask it to generate all the things, right?
yeah,
So that is our standard AI integration into software.
yep.
Okay, right. So we introduce LLM into our software engineering, and we say it's an AI application. So Manognya, what are the failures you are looking at when this is the approach?
Maybe maybe designing of the plan.
Okay.
Like if the transcript is beyond the 15K limit or something, like it will not able to accept the entire transcript.
I mean, the
It is
maximum tokens of 2 hour transcript could be 25K. So the minimum is
mhm.
usually 15K.
Okay, okay.
But not all the time the meetings would end up with 15K tokens, right?
I mean, somewhere between the 15K and 25K, there lies a number
Okay.
where usually on an average it ends off. But there could be speakers like me who speak very fast, right? Mm. So yes, so I asked this to Manogna because we spoke of something called attention window and context window, right, Manogna?
Right.
So I thought you would answer this with
Oh,
this,
yeah.
right? No worries. Yeah, I have covered this in Friday session, sir.
Okay, okay, okay.
So and also also, so in this particular approach, right? So this factor is very important. Why we can't create context? We can't create agendas out of it, and we can't create XML diagrams, or let's just say process description out of this. So let's
Mhm.
understand. Let's break it down. Okay. Mm. So that's your transcript. You pass it to LLM, and you create the number of agendas. Let's say there are only two agendas, and you create three deliverables out of these two agendas. Correct. So first thing, yeah, this phase where it has to LLM has to understand the transcript. Okay, that's our input. So it has to understand the transcript. Now this understanding, this phase one, here the explanation of attention window and context window. Okay, so yeah, standard LLMs, all most of these LLMs allow minimum of 128K tokens and maximum of like until now it's 1 million tokens as a context. But whatever it keeps as a context, it can't access it completely. Okay, let's just say within transcript within the provided input, it accesses it attentively accesses only 2K tokens, and everything else is mostly a summary. Okay, it understands it overall, but it can't pinpoint like what the thing is. Okay, so it attentively checks for 2K tokens initially, and then it summarizes the whole thing. Okay, So it is same as our attention span, right? So we look at like we start with the 2 hour video, but we come if it's a movie or anime, we may look at 2 hours. But if it's an education video, so it's more of a 10 to 20 minutes attention span, and then we start getting distracted, right? So this is the attention span, attention window of an LLM, and this is the context window is although it is 128K token minimum, but the attention window is still 2K tokens because the number is overwhelming, right? 120K tokens, 1 million tokens. So that's why these LLMs usually market based on this particular numbers. They can keep all the thing in memory, but they can't attentively observe everything within that context window. So they have something called attention window, which they can cover. Only they can cover. Okay. So because of that, even in your 15K transcript, that's the minimum, 15K token transcript, right? So it can only attentively look for 2K tokens. Everything else is mostly a summary. So once you start creating these agendas, right? Okay. So yeah, that's why it can't completely understand the transcript when you provide it to one single LLM. That is phase one. So let's look into phase two. What happens in phase two? So you have to decide between 3 agendas. So ours is 2 agendas. Let's say 2 agendas. Okay. So that is 2 agendas. So within these 2 agendas, you are creating 3 elements. That is the summary. So we have to understand. So in this understanding phase one, right? So LLMs are good at getting the things and observing it, but are not much good at generating it. So let's say it has to generate 200 tokens. It takes time, right? So it's usually 60K per minute token. Sorry, 60, not 60K, 60 tokens per minute, or let's say 80 tokens per minute. So that's how they generate. Okay. So if you, let's say the summary itself costs 200 tokens. So it will take 2 minutes to generate the whole summary. Okay. This numbers may increase. Okay. This is an hypothetical number I'm presenting. But still, once you start creating this agenda, right? So there is a summary. So you have to encode this like into a JSON. Okay. So it has to follow this instruction that it has to be in the response has to be in JSON, and then it has to follow the instruction that there should be a summary. Okay, there could be a summary dictionary, and then also if an XML could be generated, it will start generating the XML code, and the code generation, there is a syntax, there is a logical explanation, right? So it may stop somewhere, it may make some errors. Okay, we are not checking in your process, you are not checking that if the XML is usable or if the XML syntax is correct, right? You are not checking it. So it may generate it, but not completely, or it may miss a point because it has to generate a lot many things. So depending on what to generate and what's the input, these LLMs will decide how many tokens to involve in what. Okay, since you have to generate 2 particular agendas and all these 3 transcripts, so it will divide most of the time. Okay, so creating this whole thing may take like 15 minutes. Let's just say an LLM is ready to prepare it. So it may take like 15 minutes to create this whole content. But most of the chat windows we know must terminate in like 2.5 minutes, right? So this could be tricky. Correct. And also uh, first it starts summary of the first agenda. This may mix up because now it is processing 2 things simultaneously, and we know LLM hallucinates. So there could be like n number of possible ways where these 2 agendas are messed up now. Correct.
Yeah.
So yeah, Manopnya, did you understand what are the problems are in phase one and phase two?
Yes, yes, Al.
So yep. So that is what using a single LLM could end up with. Okay. So I must right. So yeah, I have an approach which I will present. Okay.
Okay.
So I call it anchor slice stitch approach. Okay. So we have to find an anchor. Depending on the anchor, we have to slice the whole transcript because passing it to single LLM doesn't make sense because of the attention window. And then based on some process, we have to stitch it back. Okay. We'll understand what it means. Yeah, deterministic anchoring, traceability at scale. Okay. It's already 36. Okay. So we are left with less than 30 minutes. Fine. I will just go a little fast if that's fine. If you want me to go slow, please stop me. Okay.
No, no, sure, you can go fast.
Okay. No worries. Yep. So yeah, I have a transcript now. So what I will do is, so instead of passing this whole transcript to a single LLM and expecting it to do the task, which I have done and I failed. So because of the attention window, so we can't let the LLM process all these 15K tokens at once. It will hallucinate. It will not understand complete sense. Okay, that are the results of it. So what I would do is, I would prepare a chunk of it. Okay, so let's just say I'm creating 3 chunks. So now it is, or maybe 4 chunks or 5 chunks, depending on whatever you want. So it is 5K tokens. Okay, 5K tokens each. So now what I will do is, so this is first section. I will pass it to an LLM. My instruction to this LLM is to generate me. Okay. So yeah, we must create. Okay. Let me answer. Let me solve this in a first draft way, and I will ask more questions. And once you answer it,
Okay.
I will just refine the way. Okay.
Okay.
So this is an LLM. So the instruction here is tell me the basically. So all these meetings have transcript. Sorry, have timestamp, right? So I'll ask this LLM to generate me timestamps where the actual discussion is happening and ignore, or I will instruct it to ignore all the rubbish talks or small talks. Okay, where the time is wasted, or let's say empty space. Okay, so that's the agenda. So I'll ask it to generate these particular timestamps. Just a second, guys. Yeah, I will ask you to create these timestamps for this particular chunk, and for the second chunk, there is an the same LLM. Okay, it's a single LLM, and there is another chunk, so it will pass it to LLM and it will generate. So now I have 3 responses which have the basically the timestamps where the productive discussion happened. Okay, so now I have an reasoning model. Okay, reasoning model. I will pass these particular endpoints to these reasoning model, and I will ask it to create and so I will ask it to create mean the number of agendas. Let's just say n value. If n is 3, it's a 3 agenda. And then depending on the number of agendas, I'm asking it to create me the summary of the agendas. Okay. Or let's just say I want this reasoning model to actually classify all these particular timestamps, right, in an order. Let's say there is an agenda 1. So all the timestamps that are responsible for agenda 1 are to be mentioned here. And there is an agenda 2. So all the transcripts that are responsible for agenda 2 are to be mentioned similarly at agenda 3. Okay, n value is 3. So 3 agendas, all the responsible transcript are into that particular JSON now. Okay, dictionary. So now I will pass this particular thing and I will stitch a new transcript. So where this whole transcript is basically agenda 1. I will stitch all these lines, and this is the transcript where it is discussing agenda 2. Now this whole thing I'm creating. So this is only speaking of agenda 3, right? Then I will pass it to LLM and okay. So I will make a mix of Manogna's and Saurabh way of passing these things to LLM. But instead of creating a mess out of it, so I will ask it to generate summary first time, the second time the XML, the third time the process description. Okay. So the same thing for this. So how good is this approach? So here to explain these, right, these terms. So anchor is where I'm creating an anchors to actually divide the things, right? So tag it somewhere. So those are timestamps. Okay. Then I'm passing those timestamp to reasoning model, and I'm actually so basically I'm doing the slicing based on this particular anchor. Anchor is like 5k tokens. That is my anchor. So I'm slicing this, and then based on this process, that is the reasoning model's capability to reason and create the agendas. So here I'm stitching the whole transcript, and then I'm passing this transcript to our DRLLM. Okay, and I'm generating the deliverables. So the number of calls could be, let's say, it's 15k tokens, and I'm dividing it by 5k tokens. So that is 3 calls, and here comes one massive call, and here comes. So this is a generation of this single call. So no worries. And here are 3 calls. Correct. So it is a total of 7 calls. So how good is this particular agentic orchestration? So it's not agentic orchestration. Let's just say, how is this good? How good is this the design?
Good.
Manogna, any doubts here?
No.
Okay, so I'm asking you guys to look for the flaws here. I have kept so many flaws here, actually.
Actually, I have a question.
Okay,
So here we are dividing tokens, and I think it's a smart thing dividing into tokens and analyzing, giving a reasoning model to it. And but the only thing is every, I mean, like each 5k tokens will generate different summaries.
I'm not
And
generating the summaries actually. I'm
sorry,
generating only the timestamps.
timestamps. But here you said that from the LLM you will create summary XML in the last step.
So that is in the stage. So this is stage where I have classified the transcript as a single agenda. So let's just say there is a lot of transcript, right? So it is a
Mm-hmm.
15k transcript, and 8k tokens of it is a single agenda. Okay.
Mm-hmm.
Now that whole 8k is fit into this particular JSON where it is providing this is responding me with all the necessary let's say timestamps responsible for that particular agenda. So by stitching it into a transcript, I have 8k token transcript here.
Okay.
Okay. So maybe the agenda 2 is of 4k tokens. So this agenda 2 could be 4k token. Okay.
Mm-hmm.
So all the 4k tokens, to recognize it, all the anchors, the timestamps are in this second JSON. So 8k plus 4k is 12k. So we are left with 3k. So let's make this 3k tokens.
Okay.
Correct. So here I have a complete transcript, not a part of it.
Mm-hmm.
Okay. So does that explains solves your problem?
I don't
That
know.
explains. Okay. So yeah, guys, find me the flaws. We are explaining like we have completed 25 sessions now, and we have been explaining the same thing. I mean, not the same thing, of course, but still, we are AI quality engineers, and our main agenda is to find the flaws. So,
Cannot think of a flaw, but like 5 division between 5k seems to be one flaw, like 5k each.
mhm.
Is it a flaw or like that's not a flaw?
I didn't get you actually. Can you repeat?
Dividing tokens.
Division, token
Okay,
dividing
dividing the whole transcript
5k
into
each.
some random
Yeah.
numbers, right?
Yes.
Okay. So, I mean, it depends on like, are we, so let's just say this 5k, I'm trying to create a summary out of it. Okay. I could go wrong here because creating summary of 5k tokens where I have split those, so that is the whole transcript and I have split it. And this, within this 5k, there is 1k, which is responsible for this agenda. Out of this
Yes.
5k, if I'm creating a summary, that could be a problem, but I'm not creating it. I'm just taking out the timestamps of this and asking a very good model to actually arrange those things based on the agendas that are discovered. Right. So even if there is an overlap, even if it's a random number, we are not generating out of it, like we are not generating anything out of it, anything meaningful. Okay. So what we are doing is we are extracting those basically timestamps. So let's just say so 11:45 somebody has started and the mic didn't work, and by 12 o'clock they started again. Okay, these 15 minutes they have resolved the mic issue and we don't need it, right? So it is removable.
Yep.
So I'm removing these transcripts basically. So these particular timelines where this is just empty space and noise. Or let's say somebody comes in and asks like what you had for lunch. Oh, that's a great lunch. I had it like 1 month ago. There was an indie restaurant. So all these, right? They are not responsible for these agendas.
Yeah,
So I
true.
could remove that. Correct.
Yeah.
So yeah, I'm doing that particular task from this 5K tokens. I'm not getting anything. I mean, I'm getting meaningful things, but that's not the overall agenda. Correct?
Yes.
Yep.
Okay. Yes. Go for it, guys. We have left with less than 15 minutes. Hmm. Okay. So the first thing, 5K, dividing the 5K tokens is fine. Passing it to LLM is a great choice. Getting the timestamp is a dumb move. But why? Because of the very first factor we know. First thing, we are not checking. Okay, there is no cross check that this model is actually, these LLMs are actually creating the transcripts. So let's just say 12:30 the meeting got ended and this model is hallucinating and providing me the transcript, the timestamp of like 1 o'clock. Does that make sense? Imagine me passing it to a Python to stitch the transcript. So that is a failure, right?
Yeah.
Okay. And then asking an LLM to exactly output a particular timestamp. Okay. With the instruction that it has to remove the empty space, empty noise. It has to remove the distracted conversation. It has to remove, uh, I mean, so let's not just remove everything. Add up the meaning out of that transcript that's been passed, extract the meaningful sentences and try to create a agenda out of it. Okay. So yeah, at instance one, this may work good. The second instance, it may work good. For the nth index, in the time, it may create blunders out of it. Okay, there could be conversations which could be like, first thing, this is the main that is hallucination. It can hallucinate the transcript, sorry, timestamp if you ask it to create. The second thing, it may mess up with the agenda. Okay, we don't have any cross verifying model to actually check if this is working correct. Okay, it doesn't have to satisfy anyone. So basically these LLMs, so all these three LLMs here are the king of their own world. So whatever they want to generate, they can generate and we are passing it down. Correct. So this we can call it LLM orchestration. Okay. And very vulnerable LLM orchestration. But we know agents, right? So we know how agent works. So why not involve the concepts here? Why not add up and make this LLM an agent and create a loop where there is an like create an agentic AI where there is a reviewer who is checking through LLM's performance. Okay, if there are things that are concerning, right? So it can provide its critical feedback to this LLM and it can regenerate before passing it to finalizing it to as these timestamps for this instance, correct? So even in this reasoning model, it is creating again this is the king of its own world. It is generating and we are just accepting it. There is no cross-modal validation here, right? We're not cross-checking the work of this particular worker node. And then here we have created the transcript. So here we are asking an LLM to generate the summary. Has it created a correct JSON format which the user is expecting? Has it created the exact XML syntax that could be run on particular platform? Okay. Has it included certain elements which are needed for our XML, let's say custom XML code? Nobody is checking it, correct? So it is creating an XML. So we need a cross-model valuation here too, correct? So are the flaws visible, guys? Any other inputs? If yes, I would be happy to hear.
So cross-checking agent means we are asking the agent to whether if from the transcript if this has been an important note, if not, just send it back and
Yes,
create
yes.
important
So
notes, just like that, right?
right, QA agent or reviewer agent, right? So what it
Yes.
does is it evaluates the work of that worker node, and if it is satisfying, it passes, or else it fails and it will provide the feedback, and the worker node has to reiterate. Again, here if you could see earlier it was a 7 LLM calls, but now we are with 7 plus LLM calls. We don't know how 7 plus n. So what's the number of n? We don't know, right? So because we are in loop now, we have included loops. So including loops is agentic AI. But we can ensure that none of this pipeline actually breaks throughout the processing, correct? Now we can ensure this, but simply LLM like orchestration. So this LLM generates this and provides the response, and next the LLM takes in, and next LLM generate this. So that could be very vulnerable orchestration. Okay, and so there are ways through which we can actually recreate these timestamps. So instead of timestamps, what I could do is, so yeah, I learned it hard way after failing so many times. But yes, so okay, this background I didn't like it. So can I clear this board, or maybe I can take up the next slide? No worries. So lost in the middle. Yes. So this
So
I explained already.
Arya just wanted to know. So while creating timestamps, does LLM creates hallucination?
Yeah, it can hallucinate. So you ask it to generate numbers 1, 2, 3, 4. By 9, it will go as 12. Or it may go as, instead of 10, it may go as 1.0. They are very bad with numbers, but they are very good with text.
Okay.
Such that even therapists are losing their job because of this. Right. Anyway, so asking it to create timestamps or extract timestamps out of a particular meeting could be tricky because it has to observe a lot many things and it has to generate very peculiar, let's say, so timestamp are in some format, correct? So it understands that format and it can generate it. No worries. So to be factual, so it is hard for LLM to be factual with those timestamps. So what I could do is, so this whole transcript, so I'll pass it through my Python function. Okay. So that's my Python function, and I will create a new transcript. So what this new transcript will have in as a new thing, right? So it will have line numbers. Okay. So from line number 1, so it may be 500 line. Okay. So I will just add up line numbers using our simple Python function. So now these line numbers are my anchors. Okay. So why line numbers? Why not timestamp is? So line numbers could be easy to read and linear, while timestamp could be like it may hallucinate in each number. Okay, so at each point it may hallucinate. Yeah, so I can add up line numbers, and depending on the line numbers itself, I can like divide the things, and then the anchoring, right? So where so this is passed to an LLM, and we are asking this LLM to generate these basically the anchors in order for us to slice it, right? So we need to stitch it somehow. So we need a particular. So earlier we said timestamp. So let's say line numbers now. So let's say I ask this LLM. I provide this LLM an instruction to generate a JSON for me. Okay. So where it is a nested JSON. So nested dictionary. Okay. For each dictionary, let's just say line number 1 to 500 is its input transcript. So this particular single part could be 1 to 500. So let's make it this 5,000 lines. So within these lines, right? So now it has to go through like 1 to 10 or 1 to 100. Okay, depending on that, it has to create me a JSON. Let's just say provide it an ID1, and let's just say create an anchor. Okay, anchor and provide the line number from which line number to which line number. So it may be arbitrary. I'm not asking it to guess 1 to 100. Okay, 1 to 50 lines. There was a productive discussion. Classify this and create my JSON. Okay, this is a part of my like whole JSON. So here I have specified that it's a 1 to 50 lines. Okay, the summary of it, and along this so even asking it to generate these line numbers, right? That could be tricky because it can hallucinate. So what I would do is, so I'd ask it to pass me a start and an end anchor. Okay, within the start anchor, so I want it to mention the line number and the 50 words, first 50 words of that particular line. So this is line number 2 and the first 50 words. If there are less words, that is fine. If there are more words, the maximum it can go is 50 words. Okay, by asking it exclusively, right? We make it to give attention to these words, and we try to avoid this hallucination. Okay, it may happen again. Okay, the hallucination still could happen, but very less often. Okay, but yeah, here again we are checking an reviewer model which has access. Okay, reviewer agent which has access to my Python function, which actually goes through this transcript and checks if that line number exists, and along with that the 50 words that we mentioned, right? If that exists in this transcript, it ensures this. If not, it will provide the feedback and it will ask this LLM to regenerate again. Okay, we may give it a threshold number of tries, that is 2 tries maximum. Okay, so now it is creating me. So it is a full proof process now. So it is, I'm making sure that it hallucinates less, and even if it hallucinates, there is a reviewer agent to handle that hallucination. Correct. So that is because I have a Python function it has a Python function which actually checks if this particular line with the line number and the words actually exist. If exist, great, it will pass it to next. So that is my first JSON. So there could be like within 1 to 500, there could be 1 to 50 lines which are productive, and then 50 to 75 lines where nothing actually happened. Okay, rubbish talks happened, and there could be 75 to 125 or more. Okay, where the actual agenda was discussed, and there could be let's say some 300 words where there was an issue, there was an rubbish talk, there was an small talk that happened. Okay, all these things. So I'm asking you to avoid these rubbish talks and small talks. Okay, I'm asking you to only focus on the agendas that's been discussed. Okay, so now I now have these two chunks as here and here. Okay, within the massive JSON that's been prepared. So I have these small JSONs, okay, small dictionaries, where each dictionary is responsible for this particular length. Okay, 1 to 50 lines, it is saying me. So this is the start and end. So depending on that, from this whole particular chunk, right? So this is the chunk. So from this chunk, I'm extracting 1 to 50 lines, and then the second productivity is 75 to 150, 125, 75 to 125. So I'm forcing it to plan one agenda, because how I'm doing it is I'm asking it to create a summary of what's being discussed, and also the reason for why it is deciding so. Okay, so these are my parameters. So I could also include few of the other elements, like within the same JSON, I could ask it to create me like flags. Okay, there is a continuation flag. Imagine this is the first. Okay, so this is 150. So here the agenda one was discussed, and this 75 to 125. So there is an agenda to discuss. So that could be tricky, right? So what I will ask is, so if the agenda is continued, okay, so I will ask this continue flag to be 1, or else it can be 0. It can either be 1 or 0. The agenda is continued, I will ask it to mark it 1 or 0. Okay. If the LLM fails, there could be another flag. Okay. So let me name it ambiguity. Okay. If this LLM is ambiguous on whether there was an agenda being discussed in these two and they are common, we can mention it. Okay. So now from this single section, right, I have this massive JSON within which we have a dictionary where the start and the end node, which is verified, are being mentioned, and the reason for it, for classifying it to be useful, and the summary of it is mentioned. Okay, and there are number of sections in similar fashion. Okay, so that is from the first section. There is another massive JSON with all these details. There could be only one part of it, or maybe no part of it. Okay, but depending on what's necessary, what's there in within the transcript, it will generate all these things, and everything will have these particular flags, this particular reasoning, and the start and the end part. Understandable? And they are verified because of the reviewer agent. We have cross-checked that those line number actually exist, correct? So we are ensuring that they are part of our transcript. So that is the magnifying glass between these first layer. Okay, maybe extended this. Understandable? So those were the flaws there, and how we could compensate those flaws. This is let's say this is how it should be presented. Let's say in a production environment. Okay, if we're actually developing such thing. If you guys permit, I can go with this second stage too.
Yep.
Anupnya, tired?
Yes, please. No.
The reply took time, so I thought you were processing. Okay, no worries. Just a joke. So yeah, so we have this 3 massive JSON now. Within each of this JSON, within each of this dictionary, there are number of dictionaries. Okay, these number of dictionaries won't exceed 4. Okay, so it is maximum 0 to 4. That's the maximum it can go. So there will be no such transcript where the discussion just flies by, and we don't have to do the micro chunking. Okay, line 1 number and 2 number was a product discussion, 3 was not. I'm not remembering it. Okay, so it is more of a approximate chunking. So now we have all these transcripts. Let's just say there are basically 7 to 9 such dictionaries where all the things are mentioned. Okay, so I have IDs now, right? So 1, 2, 3, 4, and 9. So this is the input for my reasoning model now. Okay, so now I will pass this whole information. Now my reasoning model doesn't have to look into the whole transcript. It can analyze the summary. It can analyze the reasoning behind that each of those chunks, and then try to formulate the number of agendas that are being discussed in that particular meeting. Correct? I have all the data that's needed for this reasoning model to actually create the necessary agendas. Okay, so I'm checking. So this 1 and 2 could be, so depending on so this is a linear fashion. If you could see, it is still temporal data. Temporal data. It's hard to remember this word actually. So, but yeah, temporal data means it is a time-based data. So the chunk 1 was the first section of the transcript. Chunk 2 was the second section of the transcript. Chunk 3 and so on. Correct. So the 9th chunk is the last chunk. So there is a temporal data that's being maintained. Okay, we are informing this reasoning model that you have got this data. Now within all these sections, we have something called there is a start and end anchors, and you have the summary of it. So what's been discussed between those anchors, and you also have the reasoning for classifying that anchor. Okay, why that specific anchor was classified, and also there are flags which mention if two has an number two has an continuous agenda as one. Okay, and there is an something flag called ambiguity where it is mentioned that if it is ambiguous. Okay, looking at a small transcript, small portion of it, this LLM may not recognize that to be of a single agenda. Okay, it could be of multiple agenda, but looking at this as a whole thing, right? So this reasoning model now can easily identify which agenda this ambiguity belongs to. Correct? Make sense? Maybe looking at a tail of a snake, right? So we may not identify which snake it is, but looking at the whole snake, we can, right? So that's the gist of what's being discussed here. Okay. So this reasoning model will generate the number of agendas. Okay, let's just say 3 agendas. Now, since these 3 agendas are discovered now, so now I will ask it to generate 3 elements out of it. Okay, only 3 JSONs where within this 9 particular dictionary, right? So we have start and end points. So I want agenda 1 to have all the start and end points. Okay, so that I can use in Python function to actually stitch this into a single transcript. Make sense? So it has got a reference, so and not much data. Okay, it is not overwhelmed with the input. It is a simple, straightforward, and productive input. So it would generate a good. So we do have a check reviewer. So every time there is an agent involved, we have an reviewer agent. Okay, that's a must. So now it will ensure. So we have this Python function which will create the original transcript. Okay, based on the agendas. Agenda 1, agenda 2, and this particular transcript is responsible for agenda 3. Okay, if there are no agendas, we can ask this model to generate this some particular message through which we can handle it using Python. Okay, no agendas were discussed in this meeting. Okay, we can present it to users. If there are agendas, we can go with this flow. Understandable? And also by asking the reason to classify this whole thing as a single agenda, we are forcing it to reason for its choice. Okay. Now we have this transcript where this whole transcript is responsible for agenda 1. Okay. And here, since it has already classified the agenda, we could also ask it to generate the summary out of it, correct? So here, so it has classified the line numbers already, okay, through which we can stitch this transcript. So now we can, since it has already decided this is an agenda and it has got a reason to do so. So now I can ask it to here itself, I can ask it to create a summary out of it, correct? So here we have a summary already. Summary of this agenda is ready already. Now we need to create XML and process description. XML is if necessary. Okay. So now we will pass this to particular agent, worker agent, which will go through the transcript. Now it has very less burden comparatively, correct? It has to look for very productive part of the meeting. Let's just say there were 15K tokens in original meeting. So on an average, all the transcript, all these agendas should have 5K tokens, but that's not how it works because we have removed the noise already, correct? Noise, we have removed all the small talks. So this may be reduced to 2 to 3K tokens, where the attention window of this whole LLM, right? It is fit. So now it can check through all the things in the, it's a very productive transcript now. So through which it can generating an XML and attaching an agent to check if it's an if the XML is correct and it upholds all the necessary requirements that are explained. Okay, we can ensure. So we can so there is a reviewer loop which checks if the XML generated is syntactically correct and logically correct. And if not, it will respond back and it will ask it to create another XML. Okay. And similarly, we can create process description out of it. Okay. The same thing for all these 3 sections. And finally, I have a summary. I have an XML, actually working XML code, and also a process description for each of agendas. Okay. So how does that look?
I think it creates less errors.
Right. Right. So agentic AI systems are like, that's why as the complexity increases, right? As the complexity of the task increases, LLM performance degrades, RAG's performance degrades, but agentic AI performance makes it a move. Okay, it grows better. It handles things, complex things better. So, any doubts or any improvements that are needed in this flow, or any flaws you are looking at, which I missed or may have not thought of?
So Arya, have you created a agent like this? I mean, I'm curious to see if you have created anything, how it works, and I would really like to know. It would really help us.
Like whatever we are discussing, if you had have created that,
Yeah, if
you
you
can
have
directly show
created
it to
it,
us.
if you can show us, it would
Mhm.
help
Rather
us
than talking about this,
for
let's see
better
the
understanding.
let's see what you created. That's what.
Okay. So I created this application uh, for a company. Okay. So where they
Mhm.
wanted me, so the name was content generation. So they wanted me to create these deliverables. So I didn't use agentic AI orchestration to be honest. So I created more of an LLM orchestration where I put lot of checks, lot of safety nets because the cost factor. Okay, as they are good to handle the complex task, agentic AI is no doubt costly. Imagine. So earlier it was a 7 calls. Now I have increased the calls already. Correct. So not increase the calls, but the reviewer agents. Imagine this reasoning model is generating a reason to classify these agendas, and the reviewer model is not agreeing with it. Okay, this loop could really go. And let's just say we are uh, putting up a threshold as 2 iterations. Okay, that will create three total number of times it can loop in. Correct. So 7 threes are it is 21. Correct. And in order to handle this
Mhm.
system, that is again the complexity is way more. So usually the cost factor comes in agentic AI. But yeah, if you want a promising output, that is the best way. Okay. Yeah, I have created this, but I have created using LLM orchestration, not agentic orchestration. Okay. So LLM orchestration could be very fragile. Okay. Adding this up is very fragile. And again, it may be LLM orchestration or agentic orchestration. This pipeline looks way good. But yeah, we checked through the vulnerabilities and we tried to improve that pipeline. But here, until this point, right, until even this point, we have not thought of security. Correct?
Yeah.
We have not thought of
Yeah.
the security that could be involved in this complex orchestration. Okay, yeah, that's the story for another day, maybe session two tomorrow. All right, so we will discuss on security, and again, we have to discuss on one more thing called observability. Okay, so we have print
Mhm.
statements, we have log statements in traditional Python, traditional software engineering, but they almost don't work in this agentic AI systems. How will we track which agent is working on what, which agent did how many iterations, which agent actually created uh, the actual productive output, and which agent failed to create so, and why so. So how will you understand what's happening within this? Imagine this is the whole backend, and you're providing an input and you're getting the output, and someday the output is not satisfying. So how will you identify where the application got compromised? Imagine you are handling such orchestration. So where would you pinpoint? So this particular agent in this process didn't work properly. That's why the results were off. So how will you identify that? So for that, the observability is the needed, and also, so this is more of developer's perspective. If I say, if I truly be honest, this is developer's perspective. Okay, what we call AI engineer's perspective, or we call AI architect. Usually, these are done by AI architects. AI engineer actually handle much less complex works. So yeah, that these building this application to solve this problem was their perspective. Okay, understanding their perspective is again important. So that's why I presented it anyway. But AI quality engineer. So his perspective, where did we look like security, observability, okay, traceability. So we haven't explored on that, right? So yeah, I wanted to cover that today itself. Mm, but I guess we won't be able to. So sure, tomorrow we can explore on that. And as of showing
Yep.
that particular application, maybe this actually goes public, right? So if I show that application, that could be risky for me.
Okay, okay.
Mm-hmm.
So that's basically a private application. That's why.
Yeah, okay, that's fine.
So how was it? How was the session? So was it interesting? Was it overwhelming? Did you feel like you explored a lot, or a new thing, or a productive thing, or was it a lame discussion?
Till
Nope,
now the
it was good.
session was up to certain point, and now the real things are coming up, and it's quite interesting actually.
Yes, yes, it is.
Mm-hmm.
Because
Yes, sir.
actually I was waiting for this kind of things. I know I
Okay.
don't will drag applications and all, but this is what I was actually looking for.
Yes. So understanding ABCD is good, but when you start with conversations, right? So that's where you learn English. So when
Yeah.
you try to build or solve something, so the mindset which is built in that process is actually what's the fruit of the tree is. So Saurabh,
Yep, yep.
so how is it?
It was good. Trying to connect
Okay.
the old dots, like what we have learned so far, and we are proceeding. Yep. So, yep,
So with the
going
phase we
good.
were moving, yeah, it wasn't slow, of course. The phase we were moving with was definitely not slow. Understanding RAG in two
Mm-hmm.
sessions, understanding LLM how it works in two sessions. So we have been very fast because
Mm-hmm.
we have a commitment to complete, right? But
Yeah.
yeah, I have tried my fullest to put it in detail. So this particular session, try to go over it again. Okay, one more iteration where
Mm-hmm.
you would get to know like if you would have missed some words, some meaning, yeah, that would be better understood and the fundamentals goes. Okay,
Okay.
so yes, that's for the day. If no doubts, we can end the session.
Yep. Sure.
Sure.
Sure. Good night.
Yep.
Thank you.
Have a good day, Manavnya. Good day,
Thank you.
Saurabh. Enjoy your
Yeah.
hometown.
Bye bye. Yeah. 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 Bye bye. Bye. Good night.
Yep. Thank you so much, guys. See ya.